Hello, and welcome back to the Foundation Analytics Skills Training. This is session 2. In this session, we're going to talk about monitoring and visualization of data. A brief overview of my background. I am your instructor, Michael Fitzgerald, and I have a background. My doctorate is in energy and mineral engineering from Penn State University. And in my professional career, I'm a senior analytics engineer at the Seeq Corporation. So in session 1, we spent a lot of time talking about identifying events. We looked into cleansing of data and quantifying. And so as you'll remember, when you're looking at identifying different events, that's kind of the first step you do in almost all analytic exercises. You want to pick out and figure out which sections of the data do you want to work on, what's most important, because you don't really want to run your analytics on your entire data set. You just have very specific periods. So maybe this is a temperature that's exceeding a certain threshold, and when it exceeds that certain threshold, you want to figure out maybe the duration that it's exceeding that threshold. Maybe you're looking at a density signal and you're just trying to find out the average density per day. And so you want to be able to identify first the day and then be able to calculate the average density over that course of the day. While you're working through your analytics, if you have noisy data, one of the things you may be doing here is cleansing your signals. And we looked at that in kind of the middle part of the first session. We'll also look at this in a third session. So if you're joining us for all 3 sessions, you'll see more information about cleansing signals. And then we finished up the end of the first session here with quantification. So we're looking at different aggregations, just like I had mentioned with the calculating the average density for each day, or maybe you're looking at the duration that a certain event is going on. And so you can kind of quantify that from your signal as well. In this session here, we're going to look at monitoring and also visualization of data. In the way that we monitor our data, we can look at comparing our signals versus different limits. And we can use some color coding. Maybe we're pulling our signals, we're going to do some aggregations and then report our values in terms of tables. And then we can add some color coding to those tables to just see visually when our signals are going out of range. It's just kind of a quick, easy way to figure out what's going on so that we don't have to look at the exact trend and try and make guesstimates based on our trends, but we can actually produce those values in terms of tables. We'll also look at building reference profiles. So maybe we're looking at the startup of a piece of equipment. And in the startup of that piece of equipment, we can identify that this operation is working really well. Maybe the power curve is looking really good, and we want to be able to compare that against other times where we're starting up that same piece of equipment that maybe it's running a little rougher, not as well. And so we can build golden profiles using our reference profile option here that we can then use to develop standard deviations around that and then compare that against our other signals. And you'll see that more in depth as we work through these exercises here. Another thing that we'll be looking at is monitoring our signals via assets. And so an asset structure is really where you have kind of the same measurement in a series of different operations. For this example, we have a series of cooling towers, and each cooling tower has a temperature measurement in the cooling tower. And what we want to do is just make an easy way to see if kind of the state of what's going on in that cooling tower. So whether our temperature is in spec or whether we're kind of marginally on the edge of where spec is or whether we're exceeding that. And so kind of in the image here by monitor, we can use a color coding option here to just see essentially the status and the state of our processes. If you join us for the third session here, we're going to move more into modeling and prediction, and then we'll also touch on cleansing. So before we get started, if you remember how to do it from the first session, great. If not, what we need to do is log into the Seeq learning environment by following the instructions in the CFE course documentation. In there, you should have a link that'll take you to the learning server. To log in, your credentials, your username is going to be your email address, and your password is your email address, all in lowercase. You should see a folder with your name on it. Go ahead and click on that folder. You'll have the 2 files in there, and I'll show you here in 1 second when I advance to the next screen. If you have any issues logging in whatsoever, please email us at training@seeq.com, and we'll help you get set up. Once you follow the link in the CFE course documentation, it should take you to the Seeq learning environment where your username will be your email address and your password is your email address, all in lowercase. I'm going to go ahead and log in. And when I log in here, it should take me to a folder with my name on it. And so now that I'm into the learning environment and I see the folder with my name on it, I'm just going to go ahead and open that up again. So I'll click on my name to open it up. And then again, you'll remember we have the two different files. The green one here is the Foundation Analytics Skills Training for CFE. And the blue one is the organizer training template. So we're going to use both of them throughout this training today, but first we're going to work in the organizer template. So I'm going to open that one up. And while that's opening, let's just quickly retouch on the skills that we did last time. So in the last exercise or the last session, we worked through the first three exercises here. And then we worked in organizer just a touch as well. So I'm going to come over to my analytics skills training. And as a reminder to how to find the analytics skills training page, we're going to go over here under helpful links to the right and choose interactive training. When I choose interactive training, I land at this page here. And in fact, I think you land at this page. What we want to do is navigate down to the skills menu. So in the first exercise, for the last time, we looked at identifying. And the different types of identification we did. First, we looked at a value search because we were looking at a leaking filter system, or a leaking valve rather. And so we're able to define when the material is flowing in our system, what our limit was, set a criteria that said that anytime the feed rate is greater than our limit, we're going to define as material is flowing. And we were able to use a value search to be able to pull out just those periods of time. And then we were able to pull in more information about a valve system where the valve was leaking or not the valve was leaking. So we're going to skip back. To here. Okay, so if you remember in the last session, we looked at these three different topics: identify, cleanse, and quantify. So I'll just click into each one very briefly. In identify, we were able to look at different periods of time and identify that within our signals. And we also looked at value searches. So in the first exercise where we had the filter system or the leaking valve system, and we were able to define when our material is flowing and then when our valve was either open or closed. And I'll go back into that in the exercise here in just one quick second. And then we were able to kind of combine our conditions together. We spent a bit of time looking at cleansing our signals. And then the other thing that we looked here as at quantifying. And so we used signal from condition to quantify metrics. In this case, it was our feed rate. And so let's look at our exercises that we walked through the last time. So where we left off in our last exercise, we were able to find periods when the material is flowing and use a value search to identify that period of time. That's these little magenta bars up here. And then we're able to bring in more data and look at when our feed valve was either open or closed. And that's these kind of bluish bars. Let me actually make those visible. It's the blue bars here. And then we were able to combine these two signals together and say when our valve was leaking. So whenever our valve was closed, but material was flowing, we identified and said that that criteria met that our valve was actually leaking. So we have our feed rate signal and our limit. We're able to then, once we define when the valve is leaking, go through, use the signal from condition and actually quantify what the leakage was, and then sum up for what the leakage was per day. And so we could figure out how many kilograms of material we were losing per day. So that's kind of the essence of what the first exercise was with a little add-on part there. And identify, what we were looking at was a tank level draining. So I'm going to reset this back to 3 days. And we had our tank signal that was increasing. We ended up bringing in a smoothed signal, which is kind of hidden here, but I'll unhide that one. So we used the cleanse tool to smooth our signal. And then we took the derivative and we were able to solve for the derivative. And the derivative allowed us to figure out exactly when these periods when it was draining, because we solved for a negative slope, or a negative derivative rather. And then we were able to use the value search to find when the tank level was decreasing. In our third exercise, what we looked at here was finding when the total amount of additive used each day and the cost of additive used. So we were able to bring in our feed rate signal And then we were able to go through and define a daily condition for our feed rate signal, calculate using a totalize or taking the definite integral under each of these curves here. Actually, I can just bring that signal in there too. We can see it. So we brought in and used a periodic condition to create each day. And then we were able to totalize the curve here and figure out the area under the curve for every single one of these little peaks and these little oscillations at the bottom. Solve in for the total amount of additive used each day. And then we were able to use our formula tool. We were able to multiply the cost of additive each day by the dollars. So how many dollars per kilogram of material? And then we were able to essentially get very good information about how expensive was this process per day for ourselves. We then took that information and brought it back up into ID1 and actually finished out our step in ID1, where normally we were just looking at if the valve was leaking or not. But we were able to, with that added information, then figure out the amount of leaked material, both per event as well as per day. So what we're going to do now is navigate over on the left-hand side down to MTR1, Intro to Monitoring and Tables. So I'm going to go and I'm just going to select MTR1. And then in this exercise, we're going to start really looking at monitoring. So when you think about monitoring, what you're trying to do is define some thresholds, some characteristics of the signals that you want to see, and then essentially calculate those out and put them into a table so that you can just view the different values. So you don't have to go through and look at the trend anymore, but you're essentially defining what aggregations you want to see and then reporting it into a table form. And so in this version of monitoring, using the software here, we can calculate more sophisticated operational boundaries and limits. We can concisely present multiple metrics, operating conditions, excursions, and more for an entire unit or process, or across multiple similar units in an asset so that the data are rapidly understood. We can build dashboards and report to aid in decision-making about the process. So if you can imagine, every time that you wanted to look at what was going into your process, you don't want to look at the trend itself. You just want to be able to look at a table that you've defined those thresholds and just see where your values are at within the table. In the software here, we can either look at a whole display range. So I'm just going to actually increase the size of this box. Let's do that. So we can either look at a whole display range, or we can look at using a simple table, or we can use a condition-based table to look at values over each capsule. So let's get started. What we want to do as our objective here is we want to report on the product quality, and we want to generate a table that shows the average product density each week, as well as the percentage of time per week that the density was too high. So if you remember how we bring in our data signals, I have my signal here that I want to bring in, which is the density Seeq. So I'm going to go ahead and copy that. I'm going to go up to my data tab, and I can paste in density Seeq. Search for it. I have one result. I'm going to click on it, and I see that my density signal now shows up here in my display pane. I go back to my journal, and when I look at it, what I want to see is 1 month worth of data. So I'm currently seeing 1 day worth of data. So I'll just go and click in this box between these two arrows and add in 1 month. Hit enter. And now I see some sort of a trend in time. Let's go up and add labels to this. So I'm going to click on labels, add my name to the lane, unit of measure to the axis, my condition name to the lane. And then I can just click outside that box. So now I see I have my density signal. I'm looking at 1 month worth of data, and I have my y-axis and my units, which is in kilograms per meter cubed for my density here. And so I want to use one of our pre-built tools to create a condition with a capsule for each week. So if I'm not sure how to do that, I can go back to my analytic skills, and I know I want to identify. So I'm going to go into identify. And then if I look, I have these little stopwatches here, which is essentially creating a condition based on a unit of time. And so here, if I use periodic condition, I can create conditions on either days, weeks, shifts, etc. So I want to go, I'm going to choose tools, identify, and then I'm going to do a periodic condition. I'm going to call this weekly. The duration then is weekly. Oops. And we'll just return that back to weekly. I'm going to let it start on a Sunday. I can define a time zone. Again, I'm based here in Colorado, so I'm just going to leave it at Mountain Time and choose execute. So now I see that in my 1 month of data, I have 4 capsules. It looks like that each, it looks like 5. So this one here starts off the screen, and that's what this little kind of circle with the line through it means. This capsule here is my very first one, which is now highlighted. I have 4 capsules that all show up, 2, 3, and 4. And then I have the little tail end of a capsule here that's showing off screen. So that's just kind of what we're seeing there. And now what I want to do is I'm just going to go ahead and add my information here. So I used a periodic condition to create a condition with a capsule for each week. Go ahead and bold it, we'll underline it. And then if we want to see where the capsule times start at, I can see here that each capsule starts at midnight. And if I wanted to see the duration, which they all should be 7 days, I can add a column and choose duration. And I can see that they're all exactly 7 days. So now I want to do something here to calculate the average density each week and display it in a table. Because I want to display this in a table, I'm going to go up, and we've been spending the entire time here in trend view. But we also have trend view, we have XY plots, tree maps, and tables. In this session, we're going to look at tables and tree maps. So I'm going to first choose table. And I get a very simple table that automatically generates, but I want a condition-based table. So I'm going to go up and choose condition-based. And so the table comes in, but I have 0 bits of information so far. So I want to go through and I want to add a column. And I want to add, I'm looking for the average density each week. So I can choose average. First, I have to choose the signal that I want. I'm going to choose average. And now I see I have an average density each week that shows up here. I do not like how these headers come out. I don't really want to see the entire range. It's just over every week. I'm just going to have the start of the weeks show up here. So I'm going to go ahead and change my headers, and I'm just going to choose start time. To be a little bit more accurate here under date format, I'm going to change this just a little bit. And I'm going to set this over to, let's see here. If I choose this green Q, it'll give me more information about what we're going to see. And I really like to be cognizant of the fact that I may be sharing this with colleagues who live over in Europe, and maybe they see where they write out day, month, year, where in the US here, we write out month, day, year. And so I'm going to go through, and I'm actually going to have it spell out the first 3 letters because I like that a little bit more. So I'm going to set this as month, 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 and then dot, day, day, year, year. So now we can see that this is starting on September 19th, 2021, and it's running to October 24th, 2021. So that is one way, and that is kind of a simple way that we can do tables now. And so when we look at our trend, so if I go back in the trend view, each week I was able to go through and find the average value for the density every single week. And so what the average is doing is it's calculating every single sample point and then dividing it by the total number of sample points in that time period. And that leads us to our average values here. And so that's just one style of monitoring. The other thing that we might want to do is monitor, but actually add some thresholds into it. And so we're going to really kind of follow through the steps here on this exercise. And the first thing that I want to do, I'm going to go back up into my columns, and let's see here, choose density, have the average. I'm just going to unselect that. And now I want to go, and I'm going to choose new metric. And I can type in the name for this, which is average density per week. I am using a condition-based metric. The item that I want to measure then is the density. And the statistic that I want to measure now is the average. So it's a time-weighted mean. And the condition I want to use to define my periods of time is weekly. So I can execute that step. And what we see is we get the same information that we had before in the simple step, but we have one added component here. And if I look in my journal, what I want to do now is I actually want to add some thresholds to this. And so I want to enter and essentially make the cell here turn red if my density is greater than 2.9 kilograms per meter cubed. So I'm going to go back into my density tool, open it back up, and I'm going to come down to the bottom and choose optionally enter threshold. So I'm going to click on that green plus. I'm going to choose the first option. And I can choose any number of these that I want to, but for this exercise, I'm really only interested in whether it exceeds 2.9 kilograms per meter cubed or whether it's below it. So I'm just going to choose one option here. And then I can enter my value here, which is 2.9. And so right now, if I execute this, any cell over an average density of 2.9 will turn red, and the other ones will stay the same color. Let's go ahead and make a positive confirmation that the other ones are below, and so they're going to turn green. So I can choose execute. And now what I see is anytime I'm below 2.9 kilograms per meter cubed, my cell will turn green. Anytime I'm above, it'll turn red. And just as a reminder on how we can kind of clean up these units. So when you think about significant figures, 4 decimal places here are too many, but this is reading directly from the historian and it's choosing the number of decimal places based on the number that the historian brings in. And so I'm going to go back in and I'm going to actually go to item properties this time for the signal that I'm looking at, which is average density per week. So I'll click on the item properties. And I can see that the function I used is the average. And I'm going to override on my item properties here. Then I'm just going to choose number. And then I want to set to 2 decimal places, which is the predefined number format. And then go ahead and apply it. And I'll close this. And so now I can see for my density, average density per week, I have 2.9 kilograms per meter cubed for the first week. And it has a little bit of a range to it. If I go back in to my trend view, I now see that I have my raw signal, and here's my average signal every single week. And so if I click up here, I can see that this is the average signal for this entire week, and it's keeping that same value for the whole entire week. And so what we were able to do is go through and add up every single sample point here, divide them by the total number of sample points, and the value comes out as 3.10 for this week. And this week, when we do the same thing, we come out as 1.94 or 2.07. So depending on the different types of processes you want, you can kind of color code this in different ways. And so for us, we were just really interested in any time that it's above 2.9 kilograms per meter cubed, mark it red for ourselves. And so this is just a simple way to view it. I can also go ahead and set this all to 1 lane and 1 y-axis by choosing 1 lane and 1 y-axis here. And so now I have a nice figure that I can produce that summarizes what my average values are on the same chart where my raw data is and defines the threshold within it as well. So let's see what the next step is here in our analysis. Well, first let's go back and add our details in here. So we used a scorecard metric to calculate the average density each week. So I'll go ahead and bold it, I'll underline it. And we worked through, we changed the color box to red or to green, we executed the scorecard, and we did our own date format. And again, I just like doing our date format as the 3 letters for the month. That way it's just very, very clear when I share this with any colleagues around the world that I'm talking about the month here and not the day. So I can choose transpose depending on the layout that I want to look at. So if I'm adding multiple metrics on, depending on how I want to view it, I could have all my metrics laid out here and all my scorecards laid out this direction. So the next part here is we want to find when the density is above the upper limit of 3.5. So, and we're talking the actual density and not the average density in this one. So the first thing that I want to do is I want to make a line on my trend that marks out 3.5. So I'm going to go into tools and I'm going to come down to formula and I'm going to call this upper density threshold. And then I can type in the units here of 3.5 and the value of 3.5. And then I know that this is a kilogram per meter cubed. So then I can select the units by going to the little roller here for insert unit. And I can execute this step. When I execute it, I have one solid line that shows up here that shows the upper threshold that we're looking at. So I'm going to go in, I'm going to type in formula is the option that we used here. And then we were able to put the density in this upper limit on one y-axis and one lane. So if I wanted to separate it out now and move the average density to its own lane, I'm going to go to customize. And I can see that I have lane written here. And when I click on lane, I have three different options. And the reason I have three different options is because I have three different signals available. So I have one signal, two signals, three signals. The conditions don't count as a signal. And so if I want to move the average density per week to its own lane, I'm going to move it to lane B2. And I'll also move, oops, that does not look like it did what I wanted it to. So we'll go back up to lane 1. I'm going to choose the average density here, put that on lane 2. And I'll also move the axis to lane 2 as well. And so now in this image, what I can see is my raw data, my density Seeq signal, and my upper threshold. In the lower image, I have my average density per week with color-coded thresholds on it. So if I want to find when the amount of time where my density signal is greater than this upper threshold, I can go through and I can do a value search. So I'm going to come through, I'm going to identify, I'm going to choose value search. And I'm going to call it density above upper threshold. The signal that I want to search is my density Seeq signal. The operator is going to be greater than. And then I'm going to switch over to item selector. So I'm going to choose the option here to the right, open up the dropdown. And I'm going to choose my upper density threshold signal. And then I can execute this step. And so now what I see is I have, let's actually make that show up a little bit more clearly. I have my upper density, essentially where my density exceeds the upper threshold. So during these periods of time here, this little blip of data here, as well as these two. So I can go ahead and note this in, and we used a value search to find when the density is greater than the average value, or greater than the threshold value. The next part, which is really important in our step, is not to know that it has exceeded, but for how much time has it exceeded. So to figure out how much time it's exceeded, and I want to display this in a table, I'm going to first go back to my table view. And you can see now that I have these additional spaces in here. These additional spaces are coming in because we created more signals, or more capsules rather. So first I can go into column. Oops. Okay, we'll strike that part out. Okay, so if I want to figure out the length of time that these are exceeding the threshold per week, what I'm going to do is come back into tools. We'll go into quantify, and we'll create another scorecard metric. And I'm going to call this percent time density above limit. I'm going to do it based on a condition again. The item that I want to measure now. So earlier we measured the density and we were able to figure out the time, the average density per week. Now I want to figure out the density above the threshold. So I'm going to choose that condition. And when I bring in a condition, I see that I have different options here for the statistics that I can measure. So when I scroll down, right now what I want to look at is the percent duration. I could also look at the count. So how many samples were above this limit? In this case, I just want to see the amount of time that I was above that limit. So I'm going to choose percent duration, and then I'm going to bound that by the condition that is weekly. So what I'm looking at here now is choosing the condition where we're saying the density is above the threshold. So these individual little points, these little bars up here. And I want to find the duration of each of these per week. So I'm finding the percent duration and I'm bounding it for a weekly condition, and I can just execute this step. When I execute that step, it creates another scorecard metric, similar as we did with the average density. So now let's go back and bring up the table map view of this. And so all I really want to look at is the average density above the threshold. So I'm just going to select that option. And I want to look at this based on the weekly condition. Oops, I'm sorry, my mistake here. What I want to bring in is the percent time density is above the limit. And so I can see for each week, I have the density, and this is the percent time that each of these is above the limit. And we'll add our row label here because that was missing. And so we can see in the first image, or in the first week, we're at 0%. So it did not exceed our limit at all. In our next week, we're at 21%, then 3%, so 29%. So this is just one style of monitoring. So if I also wanted to go through and add some thresholds to this, I can go back and edit. So I'll choose edit here. I'm going to add thresholds. And let's say it's very important for me to know, maybe it's not a big deal until I exceed by 5% or 10%. So let's go ahead and we'll just call it 5%. And then I'm going to execute this step. And so I can, as an easy way to monitor my data, I can just now start creating tables with a bunch of different metrics in it for my process. And this will give me kind of a one snapshot view of each week, what's going on. And remember, we define this as a weekly condition. I can define it based on the second, by the hour, by whatever time period is really of interest for me. But this allows me to go in and just very quickly and easily see what's going on in my process, as opposed to viewing it here in the trend view. And so if I was just in the trend view, I would have to look through this trend itself, look at the density above the limit, and try and make guesstimates of how much time that was or how important it was. Whereas right now in a table view, I can just look and see very cleanly and clearly how much percent of time am I exceeding my limits. So we'll go through, and I'm just going to add in here that we used a scorecard metric to calculate the percent time per week. And now what we're, sorry, what we're asked to do is go into our organizer template. And so if you don't remember how to get into the organizer template, if you still have access to your folder here, please just open up the organizer template this way. If you no longer have access, so if you've clicked on the file and it opened it up directly in that window, you can go ahead and highlight over your name and click on it and say open link in a new tab. So you can go, and when I open the link in a new tab, I should come back to my folder here. And then I can go ahead and open my organizer template. With my organizer template open, I'm going to come back down the single unit report. And what we want to do now is insert the quality monitoring figure from MTR1 into our report. So I'm just going to go in front of step 2, hit enter, and make sure that my cursor is blinking exactly where I want to bring my report into. I'll select MTR1, And then I'm going to go back up. I'm going to choose Get Link. And in the journal, I was asked to bring in a presentation link. So I'm going to come down to a presentation link, copy that to the clipboard, go back up to my single unit report. And with my cursor blinking exactly where I want to import the figure to, I'm going to choose the green queue. I'll insert a link, and then I can paste the link in here, choose Use, and I can go ahead and insert that image into my journal, or into my organizer template rather. So the next step that we're asked to do is create a date range for the previous 30 days and apply it to the figure in step 7. Rather than apply it directly to that figure in step 7, I'm actually going to recopy the figure and insert it here in front of step 8 so we can see what the difference is. So a shortcut for being able to do this, I'm just going to click on it once. I see the little blue square show up in this pop-up box here. I can do Control-C and Control-V and just paste it into the document where I want it to be. And now, just the same way that we were able to create these previous date ranges, I'm going to go through and define a new date range. So I'm going to click the plus sign here for new date range. I'm going to call this the previous 30 days. I'm going to set my duration as 30 days. And today is the 25th. So I'm going to choose Save. And then to apply it to this image, I'm going to click on the image, go to the blue queue. And now for the date range, I'm going to inherit it from the worksheet is the main option that's selected. I'm going to go down and choose previous 30 days. When I choose that, I can insert the signal, or insert the new date range, I'm sorry. And I can see that I have the previous 30 days inserted here, which as it stands is the exact same time range that's in the top one as well. So if you remember when we built this one, we have 1 month of data. So let's say that I wanted to actually change this one up and make, let's say we want to change this one and create it to 30 days further in the past. So I can go through, I can re-edit this option, and let's go 1 full-time unit in the past. We're going to go from August 26th through September 25th. So I'll save it. And now I can see I have the first month and then the current month of data available. So as you go through and you build out these organizer templates, you can really just define the different date ranges that you're interested in and have these auto update for you so that I can define kind of 2 months in a row if I wanted to, or 2 different weeks. And every week it'll just update, bringing in the current week or the new week's worth of data. And so that's all we wanted to do here in the organizer template. And that also wraps up what we're looking to do in this exercise for monitoring intro to tables. So I'm going to go through, I'm going to save my work step. And this is percent time above limit. And I'll go ahead and just insert my work step here. So now I have that preserved. Okay, so to just do a quick recap of what we did here. We went through and we were able to first load up our density signal. So I'm actually going to reset this to a trend view. We're able to load our density signal. And then we were able to define a weekly condition. So we identified the period of time of interest for ourselves. We did an average aggregation over the course of each week. And so for this week here, we averaged this blue signal here, which is our density signal. And we calculated the average value, predicted out or reported out what the average value was for every single week. We defined some thresholds for monitoring it so that we can see that anytime we're above a certain threshold that we're looking for, in this case, it was 2.9 kilograms per meter cubed. And then we were able to go through, define another upper operational threshold here, which is our upper density threshold on the raw signal, and say that anytime we're greater than 3.5, go ahead and mark out the condition where our density exceeds our upper threshold. So that would be these boxes here. Let me go ahead and highlight those really quick. And that's this condition up here in pink. And then we're able to go through and use another scorecard metric and actually find out the percent duration that we were exceeding per week. And so in this analysis, not only was the average density each week important to know, but how much time did we also exceed sort of an upper criteria threshold? So if I return back to table view now, we can see that the first week we have an average density of 2.9 kilograms per meter cubed, and we exceeded for 0% of the time. And then the next week, we had an average density of 3.1 kilograms per meter cubed, and we were in exceedance of our upper operational threshold 21% of the time. So hopefully this is an easy way to see how you can essentially bring in your signals, create conditions, identify those periods of interest, do your aggregations over those periods of interest, and then actually get down to the real information that you're looking for, which is, am I exceeding my thresholds? How long am I exceeding my thresholds? And then what information can I kind of gain from that about my processes? So with that, that's the end of MTR1. We're going to move down to the next figure here. So we're going to look at intro to bar graphs and histograms. And so histograms are just another way of looking at your data. So it's kind of another way to monitor. Let's say you work with a lot of sample data in terms of different samples, like maybe velocity samples, maybe you're looking at density samples. And so you have some sort of a process and you're pulling out every so often, you have grab samples and you're running through an analysis and you're trying to figure out how well is my system working, or what are my average values that I'm looking for. So we'll open this up and choose edit so I can edit my journal menu here, make that a little bit bigger. And so when we look at histograms, the histogram tool can also be used to calculate bar graphs, which showing a wide variety of statistics over different given bins. Statistics include average, standard deviation, et cetera, in addition to value counts like a traditional histogram would. Histograms can bin the statistical calculation by time, whether we're looking in hours, months, whatever we're looking for, the value of a signal and the condition, and histograms can contain multiple groups of bins. So in this example, we have temperature through time, and we can see kind of how our temperature is changing over time. We can also take that temperature and bin it up based on certain ranges over the course of a week. Another way to look at this is if we're looking at a pellet mass distribution for quality assurance. We have our samples in terms of different, our pellets are produced in different weights, and we can figure out what's our average weight that we're producing for our pellets themselves. We can look at it based on values, or we can look at it based on values through time. And we're going to do both of these in this exercise here. So the objective that we have is to create a histogram to view the distribution of velocity samples. Then we want to generate another histogram to view the distribution of velocity values each week or each day of the week. So to get started, we'll pull in our first signal, which is velocity Seeq. So I'm going to copy that signal, go up to my data tab, paste it in, search for it, and select it. And then I want to look at 1 month worth of data. So I'm going to go ahead and set this to 1 month. I'm going to go up and I'm going to add my labels. I'm going to choose labels. I'm going to add my name to the lane, my unit of measure to the axis, and my condition name to the lane. And so that was really the first step. We just want to bring in 1 month worth of data. So I'm going to just go ahead and be good here and save my work step. Load data. I'm going to call this load data and adjust time range. I'll go ahead and highlight it and then add in the green queue for saving that bookmarked link. So now what we want to do is use one of our tools to create a distribution of the number of velocity Seeq sample points within the given values. And we want to use the velocity signal to define the bins. So use a bin size of 0.5 meters per second. So when I look at this, this is really just a linear time signal. but actually I'm going to go ahead and change this from customize. And I just want to see the different sample points themselves. So I'm going to go and adjust this. So instead of samples being a line, I'm going to turn it to single dots. And this may make it a little bit more clear what we're actually doing here. So what we're going to do is we're going to define bars across this. And we're going to make a bin from 0.5 to 6. And all the samples in this time range that fit between 5.5 and 6 meters per second, we're going to just count up all those samples and put them into a bin. We're going to do the same the entire way across this range of values. To do so, I'm going to use the histogram tool. So I'm going to go into tools, and then it is a type of quantification that we're doing here. So I'm going to choose quantify, and I'm going to choose histogram. So I want to aggregate data and display results on a non-time series scale. And I'm going to call this a value-based distribution of velocity. The signal that I want to bring in, we only have one signal available. We're going to choose that, which is our velocity signal. The statistic we want to use, now when you think about it, what we're trying to do is actually count up the number of samples to put them in each bin. So I could use an average, and that would give me very different results. But what I really want to do is use count. So I just want to count the number of samples or capsules for each range, each bin range here. I'm going to do this based on value. And then the signal that I want to use to define the bins, I'm just going to use the velocity signal. The size of the bin is 0.5. And I could do this at anything I wanted. I could say it's just 1. So tell me everything that sits between 6 and 7 meters per second. We want a little more granularity. So we're going to go with 5.5 to 6, and then 6 to 6.5, etc. We're going to set the range from 5 to 10. So from 5 all the way up to 10, that encapsulates the entire range of data that we're looking at here. And I'm just going to choose execute. When I do that, now I see I have essentially counted all the sample points that live in each range. And between 5 and 5.5, I have 38 samples over this time period. For the next part, I have between 5.5 and 6, I have 70. So when I look at this, this really looks to me largely like a normal distribution. Depending on what's going on here, there might be a little bit of bimodal, in which case we have kind of 2 peaks occurring, but for the most part, really what I think is we have just one main peak here, and this is just a little bit high between 8.5 and 9. And so we could scroll through time. So we're at our current time right now. Let's step backwards 1 full month. See what happens. It looks like we're still holding a little bit of maybe a bimodal. You can step through. And as we look through time, maybe what we are actually having here is a little bit of a bimodal. So for some reason, 8.5 to 9.0 is actually staying higher than the 8.0 to 8.5. Now let's look at one more in the past. And yeah, that looks to be relatively accurate. So that's just a quick way we can look through and see kind of what's going on with our data, is actually just to be able to scroll through time and see how our histogram changes based on time. So I'm just going to go ahead and step back to the current time by using this green arrow that points to the right with a single bar. Okay. So I'm going to save my work step here. And I'll just insert my Seeq link here. And so for the next part then, is I want to use blank to make a histogram for the velocity distribution each day. So now what I want to do is I want to look at this. We know that this data is saved in time, or calculated in, or essentially measured over time. And what we did is we took the time domain out of this and only looked at it based on values. Now I want to add the time domain back to it and see how does my velocity samples change over the course of the week. And then adding a little bit of complexity into that, add the value-based distribution of velocity in on top of the weekly distribution. So I'm going to go ahead and I'm just going to create another histogram by going to Tools, coming down to Quantify, choose Histogram. And this is going to be I'm going to call it a time-based distribution. I'm going to call it a time and then value-based distribution. And we'll be a little bit more clear of velocity. Okay, so the signal that I want to bring in is still going to be my velocity Seeq signal. I'm going to choose that. The statistic that I want to use, we're still going to be counting. And so I just want to pull in count. And now the aggregation type, rather than using a value-based distribution, I'm going to pull over here and use a time-based distribution. And then I know I want to do it by day of the week, but I could also do hour of the day of the month, day of the year, whatever I'm looking at. For this exercise, we just want to look at day of the week. So I'm going to choose day of the week. And then aggregate capsules that overlap. This won't come into play too much for us right this second because we don't have any capsules. We're not doing it based on condition. But if you were, let's say we're doing this on a daily condition, which we're doing it on time, but we've defined days slightly different. If you're doing this based on shifts or whatever else, this here is our display range. So that's essentially from this point to this point. And we have a little bit of ability to actually look in and see if we want the entire capsules that exceed past the ends of the display range, whether they're fully encapsulated by it or whatnot. But for us, this piece here does not actually come into play in this exercise. And then what I want to do, so I'm going to execute this first, and then we'll come back and add some more information here. So when I execute it now, I see on Monday, I have 120 sample counts. This 120 sample counts says nothing so far about the actual value. Tuesday, same thing. We just have 120 sample counts. And all that means is across the course of Tuesdays, through this entire system here, we just sampled more. Looks like we sampled more on Mondays than we did on Tuesdays, and Wednesdays are about the same as Tuesdays. So this gives us a little bit more information about our process. And maybe it gives us a little bit more information about our data capture system, which is also really important to note. And now I want to try and kind of combine this image here with this image so that I have each day I can look at it in terms of values as well. So I'm going to go through, I'm going to open up my time value based distribution of velocity. And down at the very bottom, I'm going to add grouping to it. And so now I want to group based on a value. I'm going to use my velocity signal to actually create the bins. The bin size, just as we did before, is going to be 0.5. And if I execute this now, what I see here, and actually make this a little bit bigger, we no longer need our velocity signal here. So I'm going to remove it. I'm going to go to my journal, and before I do that, I'm actually just going to save a work step. And I'm going to call this time and value based distribution, but also note that it's all lanes. So go ahead and highlight it, save it, insert the work step, and now I can go ahead and create another one. So I'm just going to select the box here and go up and choose dimming. And now all we see is our velocity distribution, first based on time, so day of the week, and then actually based on value. So what could be really important is maybe in my process, I have a velocity that's really important. And so maybe my system runs better between 7 and 7.5 meters per second. Perhaps I'm running something through a reactor and I need a specific retention time. And I know that between 7 and 7.5 meters per second, that I have sufficient time in the reactor for the process to occur. So I'm just trying to figure that out. I can go ahead and click on that value that I want to see, and maybe I want to call it red. So that allows me to quickly and easily just look at my trend here and see how often is that one specific parameter showing up. So 7 to 7.5. And maybe I also want to see whenever I am at 9.0 meters per second squared, or meters per second rather, that it's just too much. So maybe I'll turn that purple. And now I can see that I only have 2 sample points that occur on Fridays. where I've exceeded it over the entire month that I'm looking at, and then another 2 on Sundays. So perhaps based on my system, this is totally fine. Maybe just exceeding it barely is not a big deal for me. Maybe it is a big deal. So this is another way that we can take our process and pretty quickly look at our velocity samples, figure out the distributions of them, scale them through time, like we did here, and then scale them through value so that we can actually figure out how is our process running. And this will allow us to then understand more about our process and begin to optimize our system. So I'll go through and I'll just add one more work step here. And this is, we'll call it just time and then value based. However we want to define this, maybe I'll just leave it as that. Highlight it, and then I can add my work step. So hopefully that's pretty clear how we were able to do this exercise. If I go back up, the first thing we did was brought in our velocity value, and then we used our customize option here that we were able to see the sample points themselves. We came through, we used a histogram here to create a distribution of the number of velocity sample points. And then the first thing we did was to create a value-based distribution. We looked at it through time. We did actually see that there may be a little bit of a bimodal event occurring. And bimodal here just means that there's 2 different peaks. So there's 2 different modes occurring. Otherwise, this would be either a Gaussian or a normal distribution. And then we used histogram again to essentially do the same thing. And the first way we did it was based on the day of the week. And then the second way we did it was including the time information into it again. So I don't have it showing here, but first we did it based on each day of the week. And then we were able to add more granularity so that each day of the week, we could also see what the velocity distribution was per day of the week. So hopefully that's pretty useful for you in understanding how we can use histograms to begin to monitor our processes, specifically anything where we're looking at maybe grain sizes or even velocities, just anywhere we have a distribution, we want to try and figure out how many samples are occurring within each bitting of the distribution. So that wraps up what we're trying to do here for histograms. And the next exercise we're going to do is this MTR4 reference profile. And as I had mentioned before, so we'll go ahead and navigate into it. This is where we're creating a golden profile. And so in this scenario, we have you can imagine like a piece of equipment starting up. So I'm going to expand this and go ahead and edit this so we can see it just a little bit more clearly. So what we're doing here is we're going to be able to compare different operation profiles to a reference profile. Our reference profile is what we're saying is a really good profile. So it's sort of our golden profile. Imagine the gray line here is a compressor power signal. So we have terms of watts on the y-axis and we have time on the x-axis. And as the compressor starts up, it uses more power. It goes through some different state and then it goes into an idle and transition period. Then it starts up again. We can define what a good startup period looks like. And then we're able to define that as our golden profile and compare the other profiles against it. We're also able to create standard deviations around that point itself and figure out how far outside of the standard deviation are we. So the first thing we want to do is bring in some data. So I'm going to bring in Q3 power Seeq. I'm going to copy that and I'm going to search for it, Q3 power. Let that load up really quick. And I'm going to bring in the Q3 power. In this case, I'm going to bring in the Q3 power Seeq teacher signal. I want to load 1 month worth of data. And so now what I can see, and actually let me add some labels to this. So I'll choose my name on the lane, unit of measure to the axis, and my name back on the lane again. What I can see here then is kind of the startup period. And actually, let me load the other signal first so it makes a little bit more sense to you. So I want to bring in now Q3 mode Seeq. And this is essentially data that tells us the mode of our operation. And that'll make more sense in 1 second. Okay. So when I look at it, I can either be in production mode, I can be in transition, or I can be idle. And there we have for idle. And so the system is starting up, it goes into production mode, drops down into transition, it's idle for a second, then goes back into production, transition, idle. And what we want to do here based on the journal is we want to find only when the system is in production modes, because we want to be able to compare each of these production modes against each other. So the first thing I'm going to do is use a value search to find when the Q3 mode Seeq indicates production periods. And so using our value search, just the way we were able to look for a closed valve, we can look on a text-based signal. So I'm going to choose tools, identify, I'm going to do a value search. I'm going to define this as production. And we'll call it production mode. The signal that I want to search is this text-based signal, and that's what this A here means, Q3 mode Seeq. The operator that I want to choose is a match, and I want to type in production. And then I can execute that step. And so now every time I'm in a production mode, I have already identified it here using these conditions, this capsule. So I'm going to save a work step. Actually add some information here. So I used a value search so that anyone else who came into my work could follow along with what I was doing here. So value search, and then we're going to call this a work step. And call it identify production periods. And oops, I don't want to bold that. I just want to insert a Seeq link. So I'm going to choose the green Q and choose the current work step. Okay, so the next part is I want to manually select a number of good capsules. All right, well, this is where it definitely relies on your ability to know your system, know your data, and know what a good production period looks like. If I change my time range here and I move into, let's say, 1 week, just to see my data a little bit more clearly in time, if I look at this signal, I see that I have these little spikes that are occurring right in the start of my production period. Who knows what's actually going on that's creating that little spike? Maybe it's a little power surge because we're looking at this in terms of watts. But that may not be something that I'm interested in capturing. Versus here where it's a little bit more smooth and clean. I think if we scroll a little bit further back, we find better signals as well. So this is where it's really important to kind of know what, when you're building a golden profile, what is a golden profile? How would you define it for your data stream very specifically? So in the instance of this exercise, I'm going to define a golden profile as not having that little spike going on and having a fairly clean trace, meaning that because I'm looking at this in terms of watts, my energy draw is really consistent. Maybe it's increasing in time, but it's not very noisy. It's not very spiky. And so I'm going to go through to be able to identify these periods here. I'm actually going to step this back out to 1 month. Now I'm going to choose tools. And I want to identify again. But now I'm going to choose a manual condition. So this will allow me to identify capsules that I think are really important that help me identify this golden profile. So I'll choose manual. And I'm going to call it good production periods. Okay. So now I can go ahead and just select them. So I'll choose this one. That looks like a good one. I'll choose this one. And so all I'm doing is going on clicking on the green, in my case, the green capsules. This looks like a good one as well. That looks like a good one. That looks like a good one. And so this is where it's really important. We're going to build standard deviations around this profile. And what we want to try and do then is have enough samples where we can really define what a good production period looks like. And then we'll be able to apply those standard deviations to the other ones. So it's up to you on how many you choose. The more you choose, the better constrained you're going to be. The less you choose, the more poorly constrained you're going to be. You're going to be basing all your standard deviations off of less average compressor startup periods. And so in this case, I have 1, 2, 3, 4, 5, 6, 7. 7 for me, I feel like that's pretty good for this scenario here. So I'm going to just choose execute. And now I've defined my good production periods. So if we want to see what those good production periods are and none of the other information intervening, I'm going to go ahead and select the little checkbox here for good production periods. I'll select the box here for Q3 power Seeq. I can choose dimming, so everything else disappears off my image. And then I can do capsule view. When I do capsule view, it's overlaying them on top of each other. If I do chain view, what I'm seeing now is each of those production periods without the information in between. So if I step back to calendar view, I can see that this period of time here, this production period does not have, I haven't defined it as a good production period. All of these ones are not good production periods, the same as that one. So I can go in the chain view and just make sure that I chose well. So this one here actually looks a little bit dicey. It's a little bit kind of rougher than I would want to consider. So I could go and see exactly which one that is. It's September 25th at 1:40 p.m. So maybe I don't want to choose that one single condition. So I can go back in for my good production periods. I can look at it, and then it was a September 25th one that I no longer actually want to use. So I'm just going to remove that one from the calculations and then re-execute this. So just stepping back one moment for what we're trying to do here. This is another spot where it's just really important to know your data, know your analysis and what you're trying to solve for to figure out if you're doing your calculations well or if you're doing it very poorly. This, by going in the chain view and looking at the different profiles that I had selected and being able to compare them, allowed me a little bit more information about the reference profile that I'm looking for in defining that it's a good profile. So I'll go ahead and just add in here that we used a manual condition. To manually select the good ones. And I will save a work step here as well. We'll call this fine, good production periods. Okay, so in the next part, what we want to do is calculate the +3 standard deviation of the given signal during the good condition periods. And so if you don't remember what the standard deviation is, this is based on the variance. And so if you have a bunch of different samples, what we're able to do is kind of look for the average value that occurs and then sort of the distance from that average value. And so to go ahead and calculate this one, the +3 standard deviation, I'm going to go in and choose tools. It's not under quantify, but it is actually under model and predict. So what we are doing is we're going to do a little bit of modeling here. And we're going to look at a reference profile. And I'm going to call this +3 standard deviation. The input signal that I want to choose is my power Seeq signal. The input condition is going to be my good production periods. I'm going to keep it gridded at every 5 minutes. And so what that means is that we break up this period of time over the good production period. And every 5 minutes, what the software is going to do is it's going to find the average value for each of these every 5 minutes, add them all up and make one profile that defines that. And then we're going to take the +3 standard deviation from there. The reference statistic then, as we mentioned, was the standard deviation. And this is going to be we could put in a +3 multiplier. So it's 3 standard deviations from this main line. And then I can execute this. And what I see now is I have my +3 standard deviation curve created. I'm going to clean up my image a little bit, and I'm going to go ahead and select my power signal. And I want my +3 standard deviation, and I want to move those to 1 lane and 1 y-axis. And so now we're starting to create our upper boundary here of what good operation is. And so we used reference profile. To calculate the +3 standard deviation. So the other thing I want to do is now create the -3 standard deviation. So I want to try and bracket in here using the deviations to figure out the range at which we're still in good operation. So an easy way to do that is I can take my +3 standard deviation signal. I'll choose the green eye, scroll all the way to the very bottom, and you can see the formula that we're starting to build out here that we're using to solve for that +3 standard deviation. But I'm going to go to duplicate. When I choose duplicate, it just creates another signal for me. And this time I'm going to call it the -3 standard deviation. I'm also using the Key3 Power Seeq teacher signal. I'm going to use the good production periods. So none of that has changed. My gridding is also the same. The only thing that I changed now is I'm going to turn this into a -3 multiplier. And then I'm going to choose execute. And then I can go ahead and add that one to the same lane, same axis again. So I'll again just choose 1 lane, 1 y-axis. And let's make this a little bit more clear of what we're actually seeing here. So I'm going to choose customize. And rather than these being in green, I'm going to turn them into red. So I'll choose my +3 standard deviation, make it red, and my -3 standard deviation to make it red. And then I'm going to, since this is sort of a modeled line, I'm going to use a dashed line here to define it. And so let's go ahead and save another work step here. And this is create the +/- standard deviation signals. I'll add a work step. And now what I want to do is actually just view this in chain view. And in chain view, what this warning sign is saying here is that I need at least 1 capsule or 1 condition to define what I want to see. So first, I want to view it on good production periods. And actually, it looks like I made 1 slight mistake here. So for the +3 standard deviations, I'm going to go back. And rather than applying it to the good production periods, I actually want to apply it to all production modes. So execute that step. Then I need to go back and do the same thing for the -3. So I'll go through and change this to just production mode here. And now, rather than looking at it based on the good production modes, I can look at it based on all production modes. And so when I zoom in and I look, Let's go ahead and add in the good production modes too, so we can see identify the ones that we said were our references. We can see how well we're performing, and it looks like we're pretty clearly within our boundaries for the plus and minus 3 standard deviations for all of our reference profiles. And now we can see where our signal is exceeding our boundaries for the other profiles. And so the last thing that I want to do here is I want to go through, and now I want to use a value search to just call out those periods of time where my compressor signal is not within the standard deviation boundaries. So that'll identify that it is operating outside of range for us. So I'll choose identify and choose value search. And I'm going to call it outside limits, operational limits. Or we could call it, let's say, plus minus 3 standard deviation. There we go. So we're going to call this outside plus or minus 3 standard deviation boundaries. The signal that we want to search is our Q3 power signal. The operator now, we're going to call it not between. Our upper limit is going to be our plus 3 standard deviation, and our lower limit is going to be our minus 3 standard deviation. And now I can execute this step. And when I execute that step, what I see very clearly here is periods of time where my system is behaving very, very poorly. And so based on the number of conditions, I can see that we are heavily outside the range that we want to be for most of these startup periods. And so the great part with this, I'm actually going to go into capsule view really quickly. And is that I can see I have my boundaries here now for the plus 3 standard deviation and the minus 3 standard deviation. I can see the profile and the trace of how my system is actually operating. And what I can see are the times where I'm not within my standard deviation. So that tells me that my system is not functioning well at these periods of time. And that when I want to look at it, I can go ahead and identify on those periods of time and dial in a little bit more of what's going on with my compressor. So this is just one additional form of modeling that we're able to use to create some monitoring. So we're able to monitor how well is our process operating by defining these boundaries. So I'll go back to calendar view here. And this is essentially the last step that we wanted to do for this exercise. So I'm going to go through and I'm just going to add in here where that we used a value search to find when the signal is outside of the boundaries. And I'll add in one last work step. There we go. So our last work step that I'm going to create here is calculate when the signal is outside the plus or minus 3 standard deviation boundaries. And I'll save that. And so that wraps it up for MTR4. And we're going to come back into MTR5. So let's navigate down and choose it. Now we're going to be looking at monitoring multiple assets. So in this scenario, we were looking at one compressor and just a period of different startups for that one compressor. Now what we're going to be able to do is monitor a bunch of different assets all at one time. And so I'll define what an asset is here in just 1 second. So let's navigate down to MTR5, monitoring multiple assets. So in this next exercise, and the last exercise that we're going to do for this session here, we're going to look at monitoring multiple assets. So I'm going to expand my journal a little bit real quick. What do I mean by multiple assets? Well, let's imagine that you have a series of different temperature sensors. You have a bunch of different cooling towers. Each cooling tower has a temperature sensor. And all you're really concerned about with this monitoring exercise is how are all my cooling towers operating? Are they within range? Are they outside of range? Can I define a certain temperature threshold that anything above that threshold, I just want to be notified? Anything below that threshold, just tell me everything is doing fine. And so what we're going to do here is we're going to use an option called tree map. And that's what we're kind of seeing in this scenario here, where we have all of our different assets set up. So we have area A, area B, area C. And what we're looking here is at the highest priority condition. And so we can mark it out for red. It says maybe our temperature is over a certain threshold. Yellow if it's between kind of a good threshold and getting up to that upper threshold. And then green if it's below that medium threshold. And so, so far this training has focused on doing calculations, finding deviations, and other things along that nature for a single or just a few tags. But what we want to do now is monitor and optimize our entire process across all sites. And we likely want to extend such an analytics across similar units and assets. This exercise explores how to swap an asset analysis to another asset and also introduces tree map view, which shows whether a given event has occurred over related assets. Both of these techniques rely on a well-built data set asset structure, which is discussed further in Seeq Advanced Training. So let's get started here. The first thing that we want to do is bring in our signal. And so previously, what we've been doing is just copying our signal and going and pulling it in. But what we want to do now is actually just navigate to it. So I'm going to go back to my data tab. And I want to go under example. So I'm going to choose example. I'm going to choose cooling tower 1. And so you can see this little box here to the left. This is showing what an asset structure is. And so under cooling tower 1, I have my different areas. No matter which area I choose, I should have a temperature sensor or a temperature measurement in each area. So I'll choose area A. Now I have my temperature measurement. I'm just going to pull that in, but then to just kind of show what an asset structure looks like, I have all these different measurements that occur in area A within cooling tower 1. If I go into area B, I have all the same measurements that are occurring, and I have another temperature measurement here. And the same, if I went through all these different signals, I should have a temperature measurement in all of them. If I don't have a temperature measurement, when I do this set of calculations, it just won't include that area into the calculation itself. So the first thing that I want to do is add my labels. So I'm going to choose labels, add my name to the lane, my unit of measure to the axis, and my condition name to the lane. And so I see that I have a temperature. And actually one more thing that I want to do here, when we haven't done this before, is I'm going to add my asset name to the lane as well. And so that is all I needed to do here. And I can see that my asset is in area A. And so I'm going to go through and now I've loaded my temperature signal and I want to use value search here to identify a medium temperature period. So when the temperature is between 85 and 95 degrees Fahrenheit, and ignore short capsules less than 20 minutes long. So I'll choose a value search. So I'm going to go back into tools, choose identify, go to a value search, and I call this a medium temp condition. We'll call it a medium temp event, let's say it. Choose my temperature signal. The operator is going to be between. My upper limit was 95 Fahrenheit. My lower limit was 85 Fahrenheit. I wanted to ignore short capsules or gaps. And if I remember this correctly, it's saying ignore capsules shorter than 20 minutes long. So we'll go ahead and choose ignore capsules shorter than 20. And then I can execute this step. So right now what I have is a medium temperature event that's occurring here. Any capsules shorter than 20 minutes are being ignored. And I'm essentially just calling out on my temperature signal anytime that my temperature is essentially greater than 85 and below 95 degrees Fahrenheit. So I can go ahead and edit this. We used a value search. And then we want to do this one more time for a high temperature event. So I'm going to go through, I'm going to identify a value search, high, we'll call it a high temp event. Choose temperature. This time we're going to choose greater than 95. And I want to ignore capsules shorter than 20 minutes again. So anytime I am above 95 degrees, I'm going to mark it out. And in fact, I only see one little spot here. So let's step back one day, maybe step back 2 days in time. And we can see where we have our high temperature event and then our medium temperature events occurring. And so in the last exercise where we're able to go through, go into item properties and duplicate the analysis, rather than doing that, I actually want to step it up one. And I want to be able to see this for all my different areas within my cooling tower. So if I'm in cooling tower 1, I can go through and I'm in area A temperature. I can go through and I can choose these arrows that point left, right, and say just swap all my calculations I did and move it over to area B. So I'll choose that option. And then this loads up. I see a little marker that says that this is swap 3 of 3 items, and it's moved it over to area B temperature now. The same way I can move it over to area C and vice versa. What I can also do, and it's probably the most useful for me here, is to go through and actually choose a tree map option. And so I'm going to choose tree map, and I get a little pop-up menu here, or a little pop-up option that says select a prioritized color for every condition in the details pane. And so here are my 2 conditions. And for the high temperature event, I want to set this to red. And for my medium temperature event, I want to set this to yellow. And so once I select the colors, I now have a really easy way to see how my operation is doing. So anytime it's red, it's telling me that over that period of time, which is going from October 22nd through October 23rd, so just 1 day worth of data, I'm exceeding my high temperature event. In area J here, it looks like I'm in my medium temperature event, but I have not exceeded my high temperature event. And then in area H, I'm only in or below my medium temperature event. And so this is just showing the highest priority color that we have. In the same way then, I can choose on area A and drill into it and see what's going on area A. I can go ahead and reset to a tree map again. And I'm in cooling tower 1. If I step up through example, I can go into cooling tower 1, and then I have cooling tower 2. And so the program itself, Seeq, is actually just looking and seeing how many areas are in with each side, and defining the size of the cell based on that. So in cooling tower 1, it looks like I have 8 areas. In cooling tower 2, I have 2 areas. So I'll choose cooling tower 2, and I just have area D and area E. And of specific note here, when I go into cooling tower 2, I also have an area F, but if I choose area F, I don't have a temperature measurement. So that's just one feature that you need to have that measurement as it makes sense to be able to swap the assets to it and run that calculation on that area. So I'm going to go back into cooling tower 1 now. And I also need to do it up here. So I'll choose example. We'll go into cooling tower 1. And the other thing that I want to do is to go through. So we'll just be good note takers here. We used a value search to identify a high temperature event. We swapped our assets. We set up our prioritized colors. And let's go ahead and save a work step now too. And we'll call it create tree map of temp. We'll call it tree map of cooling towers. You can name it anything you want though, really. And I'll insert my work step here. So the next thing I want to do is actually add some more signal statistics to each of these boxes. So I'm going to go through, I'm going to choose that we have a temperature and a statistic that I want to add. Here we'll add the maximum temperature. So I'll see the maximum temperature for each area. And then I also want to add, let's just go for it, we'll add the average temperature. And so now I can create a nice, easy way to monitor my data for all my different temperature signals without needing to go in and look at each trend itself and see where I am, where I'm at based on the criteria that I set, the different thresholds. I just have a color-coded option that just says whether I've exceeded it or not exceeded it. And so I'm going to add one more work step, and then we're going to add this over to our organizer template. Okay, so hopefully you still have your organizer template open. So we'll just go ahead and hop back over to that one. And now what I want to do is add my image here for my site-wide report. So I'm just going to add a couple of spaces here in front of step 9. And I want to insert the tree map visualization from our exercise, but I also want to use a custom dimension of 1400 by 200. So I'm going to go back to my exercise here. And if you remember how we did this before, we're going to go up to get link. So I'm going to copy the link here. I want to use an edit link. So I'm going to choose copy a link to URL. Come back to my organizer template. And then I'll insert the content by using this green Q. I'm going to insert a link. I'll paste that in here. I'm going to choose use. And if you remember, we wanted to do a content size of 1400 by 200. So for content size, I can change this from medium to custom. I'm going to change this from 1400 to 200. And then I'm just going to insert this into the document. And so I am looking at 1 day worth of data, and it's running from, looks like October 23rd at 4:46 p.m. to October 22nd at 4:46 p.m. So to go ahead and add in the additional date range here, I'm going to go and I'm going to reconfigure and define the new date range. So I'm going to choose date range. And I'll type this in as previous 12 hours. So let's set ourselves for the date range that we currently have in this image here. Or maybe let's say that we actually want the previous 12 hours from now. So I'll choose step to the current time. Set this for 12 hours. And now I have my current time and I have 12 hours before my current time. And then I can save this. Rather than applying that date range to the first image that we have, I'm going to just add it below here. And so for your analysis, it just really depends on how many different ranges did you want to show? Do you want to just have the 1 day worth of data and then the previous 12 hours? Do you want to have just the previous 12 hours? I'm going to add it again just to show how we add it and how we apply the date range so we can see the difference between the two of them. So I'm going to copy this and paste it. And now I'm going to click onto the image that I want to change the date range for. Go down and select the blue Q. And now for the date range, rather than inherit from the worksheet, because if I inherit from the worksheet, it's going to pull the exact date range from the worksheet that we have defined over there. But rather, I'm going to go in and select this previous 12 hours option and choose insert. And so now what we have is our initial date range, which is October 22nd through October 23rd. And we have our previous 12 hours from now, which is October 25th at 6 a.m. through October 25th at 6 p.m. And so with that, that kind of concludes what we wanted to look at for both all the monitoring stages, but really for the last exercise here of monitoring multiple assets. So to do a quick recap, what we were able to do is we were able to come through, and I'm going to reset this over to trend view. We're able to bring in our signal, which is our temperature signal. And then we're able to define our medium temperature event and call out those periods of time using a value search. We're able to call out our high temperature event also using a value search. And then we were able to go in and looking at the data, we're able to swap our calculations using a swapping asset function here that would swap our conditions that we created for area A and swap them over to area B. And we could do that for area C or area G. But then the simple way of doing it is actually coming in and creating a tree map where we can monitor all the different assets at the same time. And so in the tree map image here, we can see any area where we have exceeded and we have our highest priority condition. So looks like in this system, we have a lot of stuff to pay attention to and to focus on because most of our areas are exceeding our high temperature events. And we only have one area that seems to be operating well and one area, at least for this single day, that is marginal, I would say. We were then able to take and add a maximum value and an average value. So this gives us a little bit of statistics around our signals that we're looking for. And then one of the most important things we can do is taking that information and being able to share it with our colleagues. So we brought it over to our organizer template where we could then add in the different tree maps into our organizer template here and apply a custom date range to it that we can have it set up so that it auto updates every day or every 12 hours. So that imagine if you're an operator or you're a manager and you're just trying to monitor the system, you can come in and actually view the tree map in this report and just see how your process is running. So another component here that's really important is the actual ability to drill down. So I'm going to choose a presentation link. I'm just going to choose the preview option for it. When I choose the preview option, I've removed my different worksheets. I've gotten rid of the little properties tab, and all I can really see is just what's going on. So this is one way to create a dashboard that you can use, have it set up on a computer screen that you can just monitor. Now, if I shared this with a colleague and they had a question about what's going on in, let's say, area B, they're able to just click on the image for area B and drill right into it. And they're able to immediately pop into my workbench template. Note that up here in the upper right-hand corner, it says viewing only, which means that they don't have the ability to actually change anything, but they do have a fair amount of ability to go in and look at the different events that are going on. So if they're curious then on the area B, which we clicked on here, I can go and click on area B here and actually dial right into my analysis looking at area B again. And so that's how we're able to use tree maps to monitor multiple assets all at one time, simplifying our lives so that we're no longer just paying attention to the different trends themselves, but instead we're able to set criteria that essentially define how our operation is running, and then scale one step further out so that we can look at all of our different operations all at one time in a very visual way. So that concludes the last exercise that we're looking at here. And so I'm actually going to step out and go back over to my workbench analysis. So in this series of exercises, we started here with MTR1, Intro to Monitoring and Tables. We were able to use tables to look at the average density per week in the percent time duration above each limit. And then we used histograms to look at distributions, both based on value, as well as based on time, and then breaking it down based on value as well. And then we were able to define a reference profile. So we're able to look at how our equipment is operating and running, where we can define golden periods of time that say that this is really good operation. We can define standard deviations around that period of time, and then be able to use those to compare against all of our other startup, or in this case, production mode periods of time. So this allows us to say that this is what our signal should look like when it's doing well. And now I can define when I can see when my signal is not doing well, and I can use a value search to actually define when I'm outside those thresholds. And so the nice part here is if I have a year's worth of data, I can pretty quickly and easily identify periods of time where my system is not functioning well. And that tells me that I need to go in and look at it and see what's going on. And it helps me diagnose these issues. And then the last part is we got into the tree map here, which we just went over. So I won't go over that one more time again, but that is the end of session 2, all on monitoring. I hope this was very useful for you, and you can start to see now how you would apply this to your data and just different ways that you can visualize your data, more than just doing calculations, of being able to actually aggregate it using tables, looking at summary statistic values in the different tables to tell us more about our processes. And with that, I hope I see you back here very shortly for session 3, where we're going to start looking at modeling and prediction. If you have any questions or you're looking for additional resources while you're working through these exercises, Seeq makes it available where we have our knowledge base. And so this is where you can go and pose different questions and get support from analytics engineers like myself. The Seeq user community is an option where you can go in and you can see different questions posed by the community itself. And they're also answered sometimes by the community, sometimes by analytics engineers like myself. And we have our interactive training, which we had gone into over here. And so in our interactive training for monitoring, we've gone through and we've looked at our reference profiles, and we've looked at our threshold deviations, and we've looked at monitoring multiple assets and using tables. And so with that, I want to thank you for your time, and I hope you're finding these trainings very, very helpful for you. And I look forward to seeing you in the next session. Thank you.